Hi. Welcome to our Interval Project internal training. Topic for this video is structural work. What is structural? Structural is the particular method of assembling and constructing structural elements of a building, so that they support and transmit applied loads safely to the ground, without exceeding the allowable stresses in the members. Structural elements can be divided into foundation, RC shear wall, beam, slab, column. Foundation is the lowest part of a structure. It will transfer load of the structure to the soil which it is resting. There are two types of foundation. 1. Shallow foundations. 2. Deep foundations. Shallow foundations, used to handle the weight of distribution for smaller and lighter buildings, where the structures is less than 6 feet deep. For example, residential homes. Types of shallow foundations. A. Spread footing. B. Strip footings. C. Combined footings. D. Raft foundation. A. Spread footing. This type of footing is typically used for small structures, such as sheds or decks. B. Strip footing. Strip footings are used to transfer loads of closely spaced raw of columns to the ground. C. Combined footings. The combined footing is the combination of 2 column and 1 footing. The plan of combined footing may be rectangular or trapezoidal. It is provided when the 2 columns are so close to each other. D. Raft foundation. The raft, or mat foundation, is the combination of the number of columns and walls coming over a large single slab. The raft foundation is basically used in high-rise buildings. Deep foundations, used to transfer the weight of the superstructure to a layer of bedrock, down to a deep of 250 feet, to ensure structural stability. For example, skyscrapers, bridges, or warehouses. Type of deep foundation. Pile foundation, as we know, is a type of deep foundation that transfers load from superstructure to deep soil, which has high bearing capacity. Column is a vertical structural member. It's transmit the load from ceiling or roof slab and beam, including its self-weight, to the foundation. Type of columns used in construction. Reinforced concrete column, square or rectangular column, circular column. A column that is reinforced with steel is known as a reinforced concrete column. This column is majorly used in building construction. Steel reinforcement is provided to increase its tension capacity. Square or rectangular columns are mostly used in building construction. These types of columns are economically good and easy to construct because of their easy shuttering and reinforcement placement. Circular columns are mostly used in the piling and elevation of buildings for aesthetic purposes. Other than buildings, circular columns are mostly used as bridge pillars due to good resistance against deflection. Beam is a horizontal member spanning an opening and carrying a load that may be a brick or stone wall above the opening. Types of beam used in construction. Continuous beams, fixed beams, simply supported beams, cantilever beams, overhanging beams. Slab. Slab is a molded layer of plain or reinforced concrete, flat horizontal, and usually of uniform, but sometimes of variable thickness, and supported by beams, columns, walls, other framework, or on the ground. RC shear wall is a vertical structural element used to resist the horizontal forces, such as wind force or seismic force. Reinforcement bar. Reinforcement bar is a steel bar used as a tension device in reinforced concrete and reinforced masonry structures to strengthen and aid the concrete under tension. Usually, two types of reinforcement bar that used in site. 1. Mild steel bar. 2. Deformed steel bar. Example of reinforcement bar in column. The dimension of this column is 700 mm times 700 mm. 8T20 denotes 8 nose of 20 mm diameter, high yield column steel bars. 2R10, 240 denotes 2 nose of 10 mm diameter mild steel column links at 240 mm center to center distance. Example of reinforcement bar in beam. The dimension of the beam is 200 mm times 600 mm. 2T12 for top reinforcement denotes 2 nose of 12 mm diameter high yield steel bars. 2T20 for bottom reinforcement denotes 2 nose of 20 mm diameter high yield steel bars. R8, 200 denotes 8 mm diameter mild steel links at 200 mm center to center distance. Example of reinforcement bar in slab. The thickness of this slab is 160 mm. T10, 300 for top rebar denotes 10 mm diameter high tensile reinforcement bar at 300 mm spacing. T10, 300 for top distribution bar denotes 10 mm diameter high tensile reinforcement bar at 300 mm spacing. T10, 200 for bottom rebar short span denotes 10 mm diameter high tensile reinforcement bar at 200 mm spacing. T10, 300 for bottom rebar long span denotes 10 mm diameter high tensile reinforcement bar at 300 mm spacing. Next is the example of structures failure happened in Malaysia. 1. The Highland Towers collapse occurred on December 11, 1993, in Taman Hillview, Ulu Klong, Selangor, Malaysia. After a prolonged period of heavy rainfall, a landslide began, which destroyed the retaining wall behind the first block's car park. 2. On June 2, 2009, the Sultan Mizan Zainal Abidin Stadium in Gong Badak suffered a major blow when its roof of more than 70% stood collapsed, completely destroyed. On February 20, 2013, the stadium's roof collapsed again, due to a weakness in the main roof structure, after the removal of the middle framework. 3. On the 6th of June 2013, 30-meter length of a section connector of the second Penang Bridge, which was under construction, had collapsed. It has been identified to be procedural and technical negligence by the contractor that had led to the incident. That's the end of the Interval Project internal training. Thank you.